Assalamu alaikum. This class is for 8th standard. Last time we completed the chapter titled Cubes and Cube Roots. So we shall be starting a new chapter today, and I have skipped one chapter. I shall be discussing now chapter number 9. The name of the chapter is Algebraic Expressions and Identities. Chapter number 8 that I have skipped will be discussing later on. Algebraic expressions you have come across in previous classes also. Therefore, you are expected to know the definition as well as basic terms related to this. To refresh your minds, we'll go through the definition as well as the basic terms related again, so that it helps us to understand the exercises, the application part that we'll be discussing later. You have used the terms variable and constant in your earlier classes. By variable we mean the quantity whose value can change. Vary in different situations. It will take different values. That is why it is called a variable. Its value can vary, change under different situations. And you have seen in previous classes we use English alphabets, small letters. Generally, English alphabets to represent them, and frequently the alphabets used as variables are X, Y, and Z, though other variables can also be used. On the other hand, by constant, we mean the quantity whose value does not change. Opposite to this, value can change, value does not change. Means it remains same under every situation. It will remain same. That is why we call such quantities as constants. And generally we use numbers to represent constants. The number can be a natural number, It can be a whole number, an integer, a rational number. You have come across so far only these groups of numbers. So any of those can be used as a constant. And then you have, in your earlier classes, used symbols for different operations of numbers. The different operations that you have come across are addition, subtraction, multiplication, and division. Symbolically, we write, in case of addition, the sign which we call as plus sign. For subtraction, we use minus sign. For multiplication, we use this sign. And for division, we use this sign. For division, we sometimes also use simply a line, an oblique line. Now, when variables and constants are combined with each other, any of these signs, sign of addition, subtraction, multiplication, or division, then the statement which is obtained is called as an algebraic expression. Thus, algebraic expression is combination of variables and constants by fundamental operations. Of mathematics. Such a combination where variables and constants are combined by fundamental operations of mathematics is called as an algebraic expression. Later on, as you go to higher classes, you will find algebraic expressions are further classified. We have two larger groups called polynomials and rational expressions. But right now at this level, we will use only the term polynomial. We'll use the term polynomial in place of algebraic expression. So wherever you will find algebraic expression in this class, it will always mean polynomial. Or wherever you will find the term polynomial, it will to you mean algebraic expression. This is how we define algebraic expression. Some examples of these we can write. This is an algebraic expression. It involves the combination of variables. X and y are the variables, and the constants involved are 2, 3, 5. The different operations involved here are plus, minus, and you can see multiplication also there. Though the sign of multiplication is not written there, but it exists. The sign separating 2 and x, which combines 2 with x, is multiplication sign. The sign which combines 3 to y is again the multiplication sign. The combination is called as algebraic expression. It is a polynomial. We can also have a combination like 7x square minus 3x. This is also a combination of variables and constants. Variable involved here is x, and the constants involved are 7 and 3. We have used the symbol of subtraction operation there, minus sign is there. But as I said in the previous case also, sign of multiplication also exists there, though it is not shown, it is not written there. The sign separating 3 and x, a sign that combines 3 to x is multiplication sign. Likewise, the sign that combines 7 to x square is multiplication sign. It is not necessary that all the signs of operation should exist in the statement. Just one, minimum one, is sufficient. You may have sometimes more signs also, but just one should be there. Having understood what we mean by algebraic expression, the polynomial, now let us try to understand what we mean by term. Term is a part of an algebraic expression. A part of an algebraic expression in which the components are combined to each other by only multiplication sign. Components are linked to each other, combined to each other only by multiplication sign. That part of the expression is called as term. For example, in this expression, look at this part where the components 2 and x are the components here. These are combined to each other only by multiplication sign. Likewise, this part of the expression, here also the components 3 and y are combined to each other by multiplication sign. Such components, such parts of the algebraic expressions where components are linked to each other, combined to each other by multiplication sign only, are called as terms. Therefore, 2x is a term, 3y also is a term, and then 5 is also a term here. This can also be written as the product of components constant 5 and variable x raised to power 0. So it is again the product of components. You have read in earlier classes the value of this x raised to power 0, anything raised to power 0 is 1. Thus, by 5 into x raised to power 0, we mean 5 multiplied by 1. And if you multiply them, you will get 5 ones are 5, which is same as the component in the algebraic expression, the part of the algebraic expression. It is therefore again the term. Similarly, in the second expression, 7x is a term, 3x is a term. This is the part of the algebraic expression. Components are linked, combined to each other by multiplication sign only. Again, this is the part of the expression. Components here are also combined to each other by multiplication sign. Therefore, in this second expression, 7x square is a term and minus 3x is also a term. These polynomials we classify, we have some special names to the polynomials. Some polynomials we call as monomials. Some polynomials are called as binomials. Then trinomials, and so on. These are special names of some polynomials. Monomial is the special name of the polynomial which consists of only one term. Polynomial consisting of only one term is given the special name. It is called monomial. Thus, monomial is a polynomial. It is an algebraic expression to us with only one term. The example of this we can write 5x. It is a monomial. It is an algebraic expression because it is the combination of variables and constants by some fundamental operation. It is therefore a polynomial, and since it has only one term, therefore its special name is monomial. Likewise, binomial is also a polynomial. Which polynomial we'll call as binomial? The prefix here is bi, which refers to two. Therefore, polynomial with two terms is called as binomial. Two terms should be there. Then the polynomial will be given the special name binomial. Look at this polynomial, second example that I earlier gave you. 7x square minus 3x. It has two terms. The first term is 7x square. Second term is minus 3x. Does the first polynomial have two examples? You can easily find out it has three terms. The first term is 2x, second term is 3y, third term is 5. Remember, the terms, when you have to count the terms, you have to find out the plus and minus signs. The parts of the polynomials separated by plus or minus signs form the terms. So plus sign we have here, minus sign we have here. Therefore, this part is one term, this part is second term, this part is third term. Since it has three terms, we cannot call it a binomial. Whereas this polynomial has two terms, we can consider this as an example of a binomial. Some more examples we can write. 7x plus 3y. Again a binomial. Minus 2x square plus 3. Again a binomial. There are two terms in these polynomials. These are binomials. Trinomial is the special name, the name given to the polynomial with three terms. The prefix here is tri. Tri refers to three. Trinomial therefore means a polynomial with three terms. It is a special name. Polynomial with three terms is called a trinomial, and now you can say this polynomial is a trinomial. It has three terms. The first term is 2x, second term is 3y, third term is 5, minus 5. Then another term that you have come across in earlier classes is coefficient. By coefficient we mean part of term excluding the variable. Part of term excluding the variable is called as coefficient. For example, look at the term 2x in the polynomial that we wrote earlier. 2x plus 3y minus 5. The first term here is 2x. The variable in this term is x. Now the part of the term excluding this variable is 2. This 2 therefore is the coefficient of this term. It is the part of term excluding the variable. Look at the second term in that polynomial, 3y. This time the variable is y. And if you are asked what is the coefficient in this term, the definition says part of term excluding the variable. Exclude the variable, this time y being the variable, exclude it. What is left in that term is 3. This 3 therefore is the coefficient. And if this coefficient is number, then we call it as numerical coefficient. We in short call as coefficient, but can also be called as numerical coefficient, provided it is a number. Well, having discussed these terms related to the algebraic expressions, we'll be starting application part, the first exercise based on this. As we shall proceed in this chapter, you will come across different operations. Addition of polynomials will come across. Subtraction of polynomials. And multiplication of polynomials. The fourth fundamental operation of division, will not be discussed at this level. You will come across questions based on that later in higher classes. Besides these, we will be also using later identities. Some basic identities you have come across in class 7 also. We'll be discussing those later. Well, let us begin the first exercise. It is exercise 9.1 of your textbook. Question number 1. We are asked to identify the terms, their coefficients for each of the following expressions. First part of the first question, 5xyz square minus 3zy. This is an algebraic expression, a polynomial. a polynomial with how many terms? You can understand, you can see it consists of two terms. The first term is 5xyz square because it is followed by minus sign here. And the second term is after that minus sign, 3zy, that is the second term. What we have to do is, we have to identify the terms. That is the first thing. We have to identify the terms. How many terms are there? There are two terms. The first one is 5xyz square and the second one is 3zy. After identifying the terms, you have to find their coefficients. Coefficient in the first term as well as coefficient in the second term. Now to us at this level, it will always be the numerical coefficient, the numerical part, numerical component of the term. So let us write first terms. Number 1, 5xyz square. Number 2, minus 3zy. These are the terms. Two terms are there. The first one is 5xyz square and the second one is minus 3zy. Then you have to write coefficients. What is the coefficient? Just now I said it is the numerical part of the term, numerical component of the term. The numerical component, the variables, you have to exclude the variables. The variables here are x, y, z. Exclude these. What is left there is 5. That 5 therefore is the coefficient. Coefficient of 5xyz square is 5. And what is the coefficient in the second part, second term? The term is minus 3zy. The variables in this are z and y. Exclude these variables. What is left? Minus 3. That minus 3 is the coefficient. Correspondingly, second part of this question is 1 plus x plus x square. We have to identify the terms and the coefficients. The previous algebraic expression polynomial had how many terms? Two terms were there. First 5xyz square, second minus 3zy. How many terms are here? We can count and say there are 3. Because we have here sign of separation. We have here sign of separation, plus and minus sign separate the terms. This plus separates 1 from the rest part. This plus also separates x square from the rest part. There are 3 terms therefore in this polynomial. So let us write the terms. First term is 1. Second term is x. Third term is x square. These are the terms. And after the terms, let us find their coefficients. I said coefficient just now is the part of the term excluding the variable. And if you remember just now, you were told we had part of the expression in the example that I discussed earlier, minus 5. It was not the combination of real numbers and constants and variables, but we could write it as the product, as the combination. By introducing the variable there, the variable with power as 0 was introduced. You were told this x raised to power 0 is 1. Thus it is minus 5 into 1, which is again minus 5. Now the variable part here is x raised to power 0. Exclude this, minus 5 is left. This is the coefficient. Likewise, when we look at the terms here, the first term is 1. Again, it is not the product. It is not the combination of constants and variables. But we can write as we did here. We can write it as combination of constants and variables by writing power 0 of the variable with it. So 1 can be written as 1 into x raised to power 0. X raised to power 0 is again 1. Therefore, the variable part in this is x raised to power 0. What is left excluding this is 1. That 1 is therefore the coefficient. So therefore remember, in all the terms wherever you will not have the variable, you have the number only. That number is always the coefficient of that term. The variable part of that term is always taken as variable raised to power 0. The variable can be x, it can be somewhere y, it can be z, any variable can be there. You have to raise that variable to power 0. And the remaining part we call as coefficient. It is 1 here in this term. Now look at second term, x. Well, again, this is not the combination of constants and variables. Previously we had constant only, variable was not there. So we introduced that variable by writing the power 0. But what will we do this time? We will use the multiplicative identity. You have read in one of the chapters earlier, first chapter of this textbook, what is multiplicative identity and what is its role. When we multiply a certain thing by 1, its value does not change. Therefore, 1 is called as multiplicative identity. And correspondingly, x we can write as 1 into x. Multiplying by 1 will not change the value, will not change that term, it will remain x. So it is now written as combination of variables and constants. Now excluding the variable, x is the variable, you have to exclude it. What is left there is 1, that 1 is the coefficient. Therefore remember again that whenever a term of a polynomial consists of variable only, it does not have any constant, then that constant associated with that term is always 1, which is called as the coefficient of that term. And the same thing will be applied in case of third term also. Again, we don't have the constant involved. Using the same property of numbers, multiplicative identity, we can introduce 1 with it. We can write it as 1 into x square, and excluding the variable part, the part left will again be 1, which will be called as coefficient. So therefore, the terms are 1, x and x square, and the coefficients are 1, 1 and 1. 1 is the coefficient of first term, 1 is the coefficient of second term, and 1 is also the coefficient of the third term. Considering third part, is 4x square y square minus 4x square y square z square plus z square. Now find out how many terms does this polynomial have. It involves separating signs minus and plus. And when we count then the parts formed, we have 1, 2 and 3 parts. Therefore this polynomial has 3 terms. What is the first term? It is 4x square y square. What is the second term? It is minus 4x square y square z square. From this negative sign up to this plus sign, the part is the second term. And after the plus sign, we have the third term. It is z square. Now, knowing the terms, let us find their coefficients. We'll find out what is the coefficient in case of first term. Leave the variable part. X square, y square is the variable part in this term. And the portion left is, part left is 4. That 4 becomes its coefficient. Coming to second part, second term. Variable part here is x square, y square, z square. Excluding this, we have minus 4 there. That minus 4 is then the coefficient. What about third term? It is not the product again. It is not the combination of constant and variable. And in such a case, how will you introduce the constant? Yes, use multiplicative identity property. 1 will be the number used there. And that 1 will become the coefficient. This was part number 3. You will accordingly try the remaining parts of this question and let me know next time about the parts, whether you could solve them or not. In case you have any doubt as you solve them, you can contact me later, anytime, and get your doubts clear. That is all.